Okay, let's be honest. If you've ever stared at a statistical software output and felt a massive wave of confusion wash over you, when you get to the p-value, you are in exactly the right place. Welcome to today's explainer. We're treating this like a highly practical tutorial, a masterclass in foundational data literacy, designed to take you from scratching your head to confidently interpreting and reporting your results. We are demystifying the p-value once and for all today. So get ready, because by the end of this, you're going to feel incredibly empowered to handle this crucial metric. Here is our roadmap for the explainer today. We'll quickly hit what is a p-value, the decision rule, real-world interpretation, common pitfalls to avoid, and finish up with good reporting practices. We'll be using this fantastic methods cheat sheet as our foundation today. Honestly, mastering these concepts is literally a non-negotiable skill for anyone touching data. We're going to break this down piece by piece so you can take this knowledge and actually apply it immediately to your own work. All right, let's jump right into section 1. What is a p-value? Let's lay the groundwork. The p-value basically tells you how likely your data is if the null hypothesis is true. Now, think of the null hypothesis, or H0, as the prime suspect in our investigation. It's the baseline, the nothing to see here, no effect whatsoever scenario. So the p-value is the tool that tests your evidence against that suspect. It asks a very specific question. If there was actually zero effect in reality, what are the chances I would see data this extreme? And that brings us to the absolute golden rule. A lower p-value equals stronger evidence against the null hypothesis. Seriously, burn this one into your memory. When that p-value shrinks down, the credibility of the null hypothesis shrinks right along with it. A tiny p-value means the null is looking mighty suspicious, and your data is screaming that something real and mathematically meaningful is actually going on. Moving on to section 2, the decision rule, where we compare p to alpha. Knowing what the number means is great, but how do we actually act on it? Well, we draw a line in the sand called a significance level, or alpha. A super common alpha level you'll see in research is 0.05. Here's how the decision matrix works. If your p-value is less than or equal to your alpha, boom, you reject the null hypothesis. Your result is statistically significant. But if it's greater than your alpha, you fail to reject the null, meaning your results are not statistically significant. You just draw your line with alpha, and where your p-value lands dictates your conclusion. Okay, section 3, real-world interpretation and the strength of evidence. Let's take that theory and look at what you'll actually see in your output. The really cool thing here is that evidence isn't just black and white, it's a whole spectrum. If your p-value is under 0.01, that is very strong evidence against the null. Between 0.01 and 0.05, you still have strong evidence. Now, if it creeps up between 0.05 and 0.10, you've only got some or marginal evidence. And anything 0.10 or higher, yeah, that's little to no evidence. Knowing this spectrum helps you communicate the actual weight of your findings, not just an overly simple yes or no. And this perfectly illustrates what we mean in practice. Take a look at a p-value of 0.003. Because it's way under 0.01, it is highly significant. The evidence is incredibly robust. But then look at the other one, 0.25. That is well above our standard 0.05 alpha, so it's firmly not statistically significant. Notice how we're looking at the exact numbers here? Getting into the habit of reporting the exact p-value is an absolute must. Section 4, common pitfalls to avoid, or what a p-value definitely does not mean. All right, time to enter the danger zone and bust some serious myths, because people get this wrong all the time. First off, it is not the probability that the null hypothesis is true. Remember, we assume the null is true from the very start. Second, it's not the size or importance of the effect. A tiny p-value doesn't mean you just found a massive world-changing phenomenon. Third, it absolutely does not measure practical significance. You can have a statistically significant finding that means literally nothing in the real world. And finally, a small p-value does not prove causation. It shows a relationship, sure, but not that A caused B. Avoid these traps at all costs. Now, all of this naturally brings up a really critical question, one every data pro eventually asks. But what about sample size? This is a big one. The relationship here is super nuanced and has a huge impact on your results. If you have a massive sample, you can easily get incredibly small p-values for totally tiny, practically meaningless effects. It's like just throw enough data at a problem and you inflate the significance. On the flip side, small samples might give you huge p-values, even if there's a real, deeply meaningful effect going on. Your test just doesn't have the power to detect it. So you always have to look at the effect size and the context, rather than just blindly trusting the p-value. Finally, Section 5, good reporting practices and professional standards. Consider this your mandatory pre-published checklist. Step 1. Always report the specific test you used, like a t-test. Step 2, and I cannot stress this enough, report the exact p-value, like p equals 0.034. Don't fall into the lazy habit of just writing p less than 0.05. Give us the actual number. Step 3, explicitly state your alpha level. And step 4, include your effect size and your confidence interval. Since the p-value doesn't tell the whole story, this gives everyone the complete professional picture. Before we wrap up our tutorial, I want to give you a mental anchor. If the math ever starts spinning in your head, just ask yourself this one simple question. How surprising is my data if the null hypothesis is true? That is literally exactly what a p-value answers. If it's super surprising under the null, your p-value is small, and you reject the null. Interpreting this carefully all comes back to this one guiding thought. And I'll leave you with this final provocative thought for today's explainer. Statistical significance does not equal practical importance. Let that sink in. Just because an effect is mathematically detectable doesn't mean it actually matters in the real world. You've got to check your p-value, sure, but then consider your alpha, look at the effect size, and think about the bigger picture. After all, if statistical significance is just the opening chapter of the story, what will your effect sizes and confidence intervals actually reveal about your data's real-world impact? Thanks for joining this masterclass, and keep questioning the data.